we're going to go ahead and look at an ellipse here. First of all, if you notice, we do have x squared and y squared again, just like we had with circles. But this time, these values are not the same. And whether you noticed it or not, all circles have the same values for both of these guys here. So for this, what it is that we're going to do is the same as circles, is we're going to go ahead and put the x's together. Make a little space and then put the y's together. Make a little space and then throw this little bad boy onto the other side, which makes that a positive 12. Our next step is we need to factor out the 4. Now be very careful. When we factor out the 4, we have to factor out this 2. So I know with my students, when we did parabolas, many people factored it out, but too late. You need to factor it out at the beginning. So now we're going to divide by 2 and square, so we get 9. But here's the tricky part. This isn't really a value of 9. It's really a value of 36, because 4 times 9 is 36. So to even or balance the scale, I need to add a 36 here. So again, I'll repeat that. We divide this by 2 and square it. That gives us our 9. So I'm going to add a 9 into this little parentheses here, but it's really worth a total of 36. So in order to balance it, I need to add a 36 onto that side. Same thing's going to happen here. I'm going to divide by 2 and squared, which will give me a 1. But it's really worth a 16, so I need to balance things and make that a 16 over there. So then this ends up being same thing, square root, sign of the middle, square root, sign of the middle, and I add all this mess up and I get 64. With ellipses, the next step is we actually want to divide everything by the 64 because we do want it to equal a 1. So that's an important thing to understand about these, is what they're supposed to look like when we're finished. So it's supposed to equal a 1. It's supposed to be some sort of squared thing, with something underneath here. So what happens is when I divide by 64, that is beautiful, that gives me my 1. When I divide by a 64 here, those cancel, leaving this as a 4. So 16 goes into both of them 4 times there. And then when I divide by the 64 here, 4 goes into both of those, leaving this with a 16. So it doesn't always work out this way, that they're switched. I just want you to notice that. It just, whatever it is when it is reduced. And so then I get x minus 3 and and y minus 1. So the center is just like the center of my circle. I get the opposite of what's with x, opposite of what is with y. Then we have the length of the major axis and the minor axis. So to find out when you were to graph this, say we would go over 1, 2, 3, up 1 right here. To go the amount left or right, you simply square root this guy here. So 1, 2, 3, 4, 1, 2, 3, 4. And then to go up and down, you square root this one. So it's kind of like the radius, where you remember when the circle was over, the radius over here, and you square rooted that to find it. But this time we have kind of, if you will, a radius in this direction, and if you will, a radius in this direction. So again, that's up 2. So again, these two values are square rooted and square rooted from those. So the length of this axis is 4 and 4, or a total of 8 for our major axis. And then our minor axis is the length of 2 plus 2, which is a total of 4. So no, it's not always half. No, it's not always equals. It just happens to be this way in this case. But I always do need to square root this, find that value, and then multiply that by 2 for the total length of the major axis, because this would be what my ellipse looks like.